Hello, this is Mr. Craig, and I've had a couple students ask about stock solution preparation and then going from the stock solution to a dilute solution. So I'm going to do a couple problems to actually illustrate the calculations involved with that, and then I'm going to have my son Samuel help me make these. Alright, so here's our first question. It says, number one, give the instructions for the preparation of 500 milliliters of a 1.5 molar nickel 2 chloride stock solution. Alright, so here's what we're going to do. We aren't given any information about whether we start with a solid or if we start with a liquid. If there's no indication telling you if you're starting with a solid or a liquid, you must start with a solid. And actually, what we're going to be using is our nickel 2 chloride. So it is a granular form. And you have to ask yourself, how am I going to know how much of this I need to make 1.5 molar with a volume of 500 milliliters? All right. So what we need to do is we need to find out a mass amount of this, because what my son's going to do is he's actually going to measure this out, weigh it out on a balance, and then place it in our flask to make the solution. So what we need to do first is find out what mass we need to take from this bottle to make our desired amount. So the first thing that we need to do, you always have to ask yourself, do I know the volume? Do I know the molarity? If the answer is yes, that I know the volume and the molarity, you always start with the volume. All right? So that's what we want to do. We want to start with our volume. So we have 500 milliliters. That's how much we're going to make. So that's how much we have. Since molarity, again, is in moles per liter, we have to change the milliliters to liters. All right, so that's the first thing that we must do. So I'm going to change the milliliters into liters, and again, with our factor labeling, if it's not the unit that we're looking for, we want to move it diagonally. So I'm going to put milliliters down here, liters on top. Which one's bigger? Well, a liter is larger than a milliliter, and then we have 1,000 milliliters in a liter. And I don't mean to belittle that fact, but I want to make sure everybody understands. There's 1,000 milliliters in a liter, not 1,000 liters in 1 milliliter. All right, so now if we stop right there, we have 0.5 liters. Okay, that's the math that I did in my head. So now to find out how much we need to measure out, we got to find out how many moles, because we know our volume here. So now we got to find out our number of moles. So here I have a 1.5 molar solution, so I'm going to put 1.5 moles, and this is of nickel 2 chloride. Again, nickel, Ni, chloride, Cl. Nickel has a +2 charge. How do I know that? Because the Roman numeral 2 there tells me that it has a +2 charge. Chloride has a -1, so that means I have NiCl2. Okay? Liters cancel out, now we're with moles. I don't know how to measure moles, so I've got to do one more conversion. Since my balance doesn't measure moles, it measures grams. So I need to do one more conversion. I'm going to convert these moles into grams. And that's nickel 2 chloride. Now, I don't know the molar mass of those, so let's see. Nickel is 58.69 grams for every mole. And we have 2 chlorines, which is 35.45 grams. So when we add all that up, that'll tell us how many grams Samuel needs to measure out. So we need 97. Samuel will need to measure out 97.19 grams. And our analytical balance will measure out to 1/10, so he needs to measure that out. All right, now, since we know the mass amount, now we need to actually give the instructions, okay? So here's what we're going to do. Samuel is going to measure out the 97.19 grams of the nickel 2 chloride, and he's going to place 97.19 grams of what we're looking for, okay, of nickel 2 chloride in a volumetric flask. And a volumetric flask is a unique measuring device that we use in chemistry. Okay, it's rather unique in that it only has one marking, one measurement, and there's a single line there. I don't know if you can see it on here. Okay, that's our marking for this flask, which is 500 milliliters. Okay, so we're going to place the 97.19 grams of the nickel 2 chloride in the volumetric flask, and then Samuel will add enough. Okay, and that's key here. We don't know how much water Samuel's going to add, but he's going to add just enough water that once that solid's placed in there, that it will get to that line right there, which will equal 500 milliliters. So he'll add just enough water, and we'll use distilled water or deionized water. Add just enough water so that the total volume, okay, the total volume of the solid and the water that we've added, the total volume equals, equals 500 milliliters. Okay. So again, we're going to place 97.19 grams of nickel 2 chloride in a volumetric flask, and then we're going to add just enough water, so that the total volume equals 500 milliliters. By doing that, you're going to prepare 500 milliliters of a 1.5 molar solution of nickel 2 chloride stock solution. Okay, let's go ahead and do that. All right, guys, Samuel is going to show us how to prepare this solution, the 500 milliliters of the 1.5 molar stock solution. Samuel, do you want to say hi? Sounds good. Let's get busy. So first, we take the nickel 2 chloride. Is that nickel 2 chloride, Sam?
Yeah.
Okay, let's see. Bring it up a little closer to the camera. Perfect. Okay. Go ahead and measure out the 97.19 grams. Go ahead and measure that out for me. Now go slow because it might pour out fast. Be careful you're not shaking that across town here. There you go. Okay, what mass are you at right now? What's the mass right now?
37.34.
Good. Okay, so you're not at 97. Be careful how you're shaking that, buddy. Okay, we're at 54 right now. Okay. All right. All right. Let's start. We're getting real close. We're about 20 grams away. Why don't we start scooping it out now until we get to our mass? Okay. And carefully make sure everything's over the thing there. Okay. Get a little more out of that. All right, good job, Samuel. You have 97.19 grams of your nickel 2 chloride. Let's go ahead and add it to our volumetric flask. All right, Samuel, go ahead and get the 500 milliliter volumetric flask. All right. So now what we're going to do is we're going to take our 97.19 grams of the nickel 2 chloride and place it in our volumetric. Now you're going to place the nickel 2 chloride in the volumetric flask. But we have to do this a little at a time since that is a lot of nickel 2 chloride that we have and we don't have a very large opening. So let's go ahead and use our funnel for this one. Okay. And go ahead and put a little bit at a time. Go ahead and hold that carefully, like a bread basket. There you go. And go ahead and use your spatula. Add a little bit at a time without spilling any. Carefully. Okay, drop it. Oh, good. Keep going. Get in as much as you can. And if we need to, we'll actually place some distilled water in there to help get it in. Okay, just take your time here. Good. Okay. Okay, go ahead and put that down for a moment. Go ahead and take the distilled water and rinse the inside off so that we can actually rinse the inside. There you go, squirt it all around. Make sure that it all goes down. There you go. Get it all off of there. Okay. All right, go ahead and add some more there. Good. Go ahead and add some more. You're good. Add some more nickel 2 chloride, carefully without spilling it, because we have exactly 97.19 grams of it. Awesome. Samuel, go ahead and rinse the rest of that down, and be careful not to squirt any on yourself. You got a lot in there, and that was a good job, bud. Okay. Now, somebody might be saying, now, wait a minute, you're adding water already. Remember that the total volume that we need to add to this solution needs to be 500 milliliters. So it's okay if we're adding some water right now to help get the ions in the volumetric flask. And if you look at it closely, and I'll try to zoom in here. If you look at it closely, it kind of looks like some of the granules. Now slow down, bud. Slow down. Okay, let some of that water go down. Relax. Okay, as you notice that we're not even getting close to that 500 mil mark yet. All right. Okay, we're almost got it all out of there. Good. Get it all in there. Nice. Get it all. All right. Excellent. Good. You're good. Okay. Nice job. All right. So Samuel has all of the solid in the volumetric flask, and he's rinsed off the cone. Go ahead and remove the cone from there, Sam. Nice job. All right. Now, what we need to do, go ahead and set that down. There you go. What we need to do now is we need to add enough water so that the total volume is 500 milliliters. And 500 milliliters, the mark is right there, and I don't think you guys can see that on the camera. But we need to add some more water to this. So let's go ahead and do that. All right, so we need some more distilled water. Samuel, why don't you go ahead and get about 90 milliliters of water. Get it inside the flask or in the graduated cylinder. Shut it off. Okay. Good. Okay. All right, Samuel, go ahead and add that water to the volumetric flask. Now, you may need to use a funnel to do this. So, I don't think we have enough in there, so it's okay if you add all of that. Okay, so now we're putting in more water. Good. So it looks like we need some more. Why don't you go ahead and grab some more water. Go ahead and add that, about 90 mils of water. Go ahead. I don't think you need to hold the funnel. All right, so right now looks like we're a little over halfway. Now, what's really neat about this is, if we were to look at this, we know that based on solubility rules that nickel chloride is soluble. However, I bet if you looked on the bottom of this, you'll still see some crystals on there. So typically what we want to do now is kind of shake it up a little bit. Mix it up, stir it. Sometimes we may need to put a stirring rod in there. If I put a stirring rod in there right now, you won't be able to see it, a magnetic stir. So we'll just keep kind of shaking it up a little bit, dissolving it. Samuel, why don't you go ahead and get some more water here while I'm giving it a little bit of swirl. Okay, so the crystals are starting to dissolve a little bit more, or deionize, or break apart. Okay, as I look, it looks like there's just a few more crystals in the bottom of that floating around. Not too bad. We're almost there. Okay. Now, we're getting a little closer, so start to take your time on adding the water here. Go ahead and put your funnel on there. Now, you don't have to hold that funnel with your hand. You don't need to. Okay. And as we start getting close, slow down. Okay. All right, so we're getting closer. I would say 90 milliliters next time would be too much. All right, so now we're going to get a little bit more water there, Sam. Go ahead. Get a little bit more, maybe about 50 mils. Go ahead and put 60 in. We may not use it all, but that's okay. Got it? Okay. All right, now here's what I want you to do. I want you to add enough water until it starts, until this level starts getting into the neck, okay? All right. And again, where we're shooting for is that line right there. So go slow on this. There you go. There you go. All right, slow it down a little, slow it down. Okay, so we are really close, okay? Yeah, go ahead and add the rest of that. Okay, so there's enough. All right, now here's what I want you to do. Actually, let me give a little shake here. Kind of mix it up a little more. Okay, since we're real close to that line, I want the bubbles to kind of go down a little bit. All right, do you see that line, the 500 milliliter line right here? I want you to take the blue bottle and slowly add enough until you're right to that line. So we're going to add just enough and go slow. Okay, when that water level is right there. Is that it? Awesome. Samuel, you have just prepared, you've prepared 1.5 molar solution of nickel 2 chloride that has a volume of 500 milliliters. Okay. Now, when I look at this, would you say that's a dark green color, kind of more at the bottom than it is at the top? Would you say that's dark green? Yes? They can't see you nod your head, so yes or no?
Yes.
Okay. So now what we're going to do is we're going to do, this is our stock solution. So we have a 1.5 molar solution of nickel 2 chloride. Now I want us to do something with this. Nice job on making the 500 milliliters of the 1.5 molar solution of the nickel 2 chloride. Here's what I want you to do next. I want you, using the stock solution we just prepared, I want you to take 54 milliliters of this stock solution from the 500 mils, and I want you to add enough water to make a total volume in a different volumetric flask that has a total volume of 200 milliliters. Then, let's calculate the new molarity. Samuel, we're going to need 54 milliliters of this. Could you please measure out 54 milliliters of it? And be careful here. Take your time. This is not a hurry or a rush. You're about 20, 30, 40, 50. Slow it down. Whoa! Oh my goodness. That is either good or beginner's luck by all stretch of the imagination. That is ridiculous. 54 milliliters. Fantastic. All right. All right, Samuel, go ahead and take the 200 milliliter volumetric flask and add the 54 milliliters you just poured out. Okay, you might need a funnel for this one too. Okay, and carefully pour it in. Make sure all 54 milliliters gets in there. Here, hold on a second. There, you're good. Go ahead. Carefully, slow down. Carefully, make sure it all goes in. All right, excellent, excellent, fantastic. Okay, now go ahead and from the same graduated cylinder, go ahead and get about 90 mils of water. Okay, go ahead and add it slowly. Add it slowly. So slowly add the water. Slowly. I want to make sure that you're not adding too much. Don't tip it over, big boy. Don't tip it over. Don't tip it over. Don't tip it over. Slowly pour. Okay, there you go. Good. All right, keep going. You're going to be good there. All right, probably about another 20 milliliters of water. 20. 20. Now, be very careful at this point when you're adding it that you don't add too much, okay? Add maybe just a little. Once it gets in the neck. Now, wait a minute, stop. Can you see where you're pouring and the level of that water as it rises? Okay. So again, when it starts getting to the neck, cut it off, okay? Stop pouring. Slowly, 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 slowly. Stop, 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 stop. Okay, now take your water bottle, take the funnel off, and go ahead and add it to the line. No, the funnel in there. There you go. Now add just enough water so that you get it to the line. Can you see the line on that?
Yeah.
Okay, add enough on there. All right, easy, Bubby. Get it right to the line. Nice. Excellent. All right. Now, let's do a little comparison here. Now, Samuel, you have taken how many years of chemistry so far in your lifetime?
0.
0. You've not taken any chemistry in your life. Would you, Ken, I'm asking your unbiased opinion here, which of the two volumetric flasks or which of the two containers looks darkest? The one on the left or the one on the right?
Left.
The left. The one that's a 500 mil, right? So this is our concentrated solution, which should be darker because it has more nickel chloride than this one. I'm going to quickly pour out 54 milliliters of this myself. Okay, man, I'm good. All right, here's what I want us to do. Talk a little story about Little Beaker, okay? When we look at these two solutions, and it's not so apparent right off the bat here, that when we look at these two, these actually have the same coloration, okay, the same darkness. The reason why this one looks a little darker is because it's a wider base. However, if I were to ask you which of these has greater molarity of these two containers, I would hope that you would say they're the same. However, when we look at the graduated cylinder, or in the case of my lecture video, Little Beaker, the amount of moles of particles here are the same here and here, okay? So the molarities are the same, the moles are the same. So when we look at how many moles we have here, and then we added enough water to dilute this down to a total volume of 200 milliliters, the number of particles in my container here is the same as my container here. My concentration is the same here and here. They are not the same here and here because, again, we took this and then we added some water to this volumetric flask to dilute it. Now what we're going to do is we're going to do a calculation to see what the molarity for this solution is. Let's do that. From our stock solution, we were able to prepare a dilute solution. Now let's go ahead and answer the question that was asked here. We want to calculate the new molarity of our 200 milliliter dilute solution. Now what was cool was when we talked about in the previous part there that the number of moles are the same. So we actually know the molarity, which is 1.5 molarity, and we know the volume, which is 54 milliliters. So if you know the volume and the molarity, is it possible to determine the number of moles? The answer is yes. So if we can, and we'll need to do a short calculation to determine the number of moles in here, once we know how many moles we have in our little beaker, or in this case our graduated cylinder, that we placed in here, and then added enough water, we can then calculate the molarity for this solution. Let's do that. All right. So we took 54 milliliters of our 1.5 molar solution. Again, that's what this represents. 54 milliliters of our 1.5 molar solution. So what I want to do is I want to find out how many moles that actually is. So if you know the volume and the molarity, again, start with your volume. So we have 54 milliliters. Again, convert that to liters. There's 1,000 milliliters in every liter. And we also know that we have a molarity of 1.5. So this is as far as we need to go. We can find out how many moles we have there. So let's do that calculation real quick. So 54 times 1.5 divided by 1,000. So that gives us 0.081 moles of our nickel 2 chloride. Once you know how many moles you have, it asks us to go to a total volume of 200 milliliters. So now we can find out what the new molarity is. So you take your number of moles and divide it by the total volume, which in this case is 200 milliliters. Also realize that there's 1,000 milliliters in every liter, so this is actually equal to 0.2 liters. So 0.2 liters, we have our moles over our liters, which gives us molarity. Take that value, divide it by 0.2, and that will give us a molarity of 0.450. Now, here's one thing that I want you to recognize. and this is a real quick check. This is our dilute concentration. This is our concentrated concentration. So this is our stock, this is our dilute. And that actually helps us to see that that's the reason why this is darker, where this is a little bit lighter. The heavier concentrated means we have more particles per liter than this one, which doesn't have as many particles per liter. Here's another way that you can answer a stock solution to a dilute solution type question. And it's very similar to the last problem that was worked out. Here's the question. It says, give instructions for the preparation of 200 milliliters of a 0.405 molar solution of nickel 2 chloride from a 1.5 molar stock solution. Okay? So what we're wanting to do is we actually want to finish, or we want to end up with a volume of a 0.405 molar solution that has a volume of 200 milliliters, which we have right here. Now I need to know what volume of the solution I actually need. So what I need to do is, the big question is, I need to know what volume from the stock that I need to make that solution. So this is the part that I need to actually answer the question. All right, so again, if you know the volume and you know the molarity of the solution, that's where we want to start. Now, where we're going to work backward from the other type of problem is that we know the molarity of my final substance, and I know the volume of that final substance. So what am I looking for if I know the volume and the molarity of this substance? That's right, the number of moles. So that's what I want to find. I want to find out how many moles I have in my dilute solution that I prepared from my stock solution, which is a lot more concentrated. It has a molarity of 1.5, and this has a molarity of 0.405. Okay? So let's find out how many moles we actually have. So I'm going to take my volume that I'm looking for, 200 milliliters, and again, this is of my dilute solution. I have 200 milliliters. Let's convert that to liters. Okay, so we have our number of liters here. I'm going for a 0.405 molar solution. And this will tell me how many moles I need. And I need to know how many moles. That's our common variable for this. So that times 0.405 gives me 0.081 moles. Okay? So that tells me in this 200 milliliter container that has a concentration of 0.405 molarity, I have that many moles of nickel 2 chloride in it. Okay? Now, my question is, I need to know how much of my stock solution I need to pour into this that I pour into my empty, pretend this is empty new 200 milliliter flask, and then I'll add just enough water. We don't care how much water we're going to add, we just need to add enough so we have 200 mils. So I want to find out what volume I need from my stock solution. So what's pretty cool here is that we know the number of moles that we need for our dilute. We have our molarity from our stock, and again, remember that the 1.5 molarity is actually equal to 1.5 moles for every liter. All right. Now, what's really neat is I don't even have a whole liter of this, but if I did, I'd have 1.5 moles of it. Okay, I have 500 milliliters of that. So if I only have 500 milliliters, how many total moles of this solution do I have? That's right, 0.75. So I have half of that. But that's not what we're looking at. For every liter of that solution, I have 1.5 moles. Okay. So I know my moles and my liters. I know my moles that I need. So I have this and this. Is it possible to take these two values here and find a volume? Very good. We want to start with our moles. We're going to start with our 0.081 moles. And our molarity has moles in it again. So if it's not the volume or the value that you're looking for, we're going to move it diagonally. So we got to have moles down here. We're looking for volume, so we're going to invert this. So I put the 1.5 moles for every 1 liter. You can do that because it's factor labeling. We can invert the units because what this is saying is for every liter of that solution, if I had a liter, I had 1.5 moles in it. Or if I had 1.5 moles, that equals 1 liter. All right. So now my units for moles cancel out, and I'm left with liters. So let's go ahead and find out what that is. So I get 0.054 liters. Okay. So that means I need 0.054 liters. Well, when I look at this, this is in milliliters. So let me convert that from liters to milliliters. So I'm going to take my 0.054 liters and do a conversion. And that equals 54 milliliters. Okay? Now, we're not done yet because the question still asks us to give instructions for that. Okay? So we know that we need 54 milliliters from our stock. We need 54 milliliters of our stock. We're going to pour it in this volumetric flask, 54 milliliters, and then we're going to add just enough water so we get a total volume of 200 mils. I just gave you the instructions. Isn't that cool? So let's write that down. Let's slide this board, actually slide this board over. Okay. So what we're going to do is we're going to place 54 milliliters. We're going to measure out. We'll measure out 54 milliliters and then we'll place it. We're going to place 54 milliliters of a 1.50 molar solution of nickel 2 chloride in a volumetric flask. Okay? And again, volumetric flasks are these funny looking things, but they're very, very, very accurate. Okay, so we like using this, or precise, we should say. So we're going to place 54 milliliters of our stock solution, 1.5 molar nickel 2 chloride solution in a volumetric flask. Then we'll add enough water. Notice that there never is an exact amount. You're just going to add just enough. You're going to add just enough water to get it to that level, that line right there. Okay? So we're going to add just enough water. And again, this is understood to be distilled or deionized water. We're going to add just enough water so that the total volume equals 200 milliliters. Okay? There's your instructions. When going from a liquid to a liquid, that's what we have to do. We have to find out what volume we need to measure out from our stock whenever we're doing a problem like this. Okay? So the key here is, again, we first of all need to find out how many moles of the stock we have in our volumetric flask, in our dilute. We need to know how many moles we have. Once we know how many moles we have, then we need to remember what our concentration of our stock is and use that value with the number of moles that we just found to get a volume. Okay? Once we know what the volume is, then we can prepare our solution. Okay?